Hey, welcome back. This is the first in the video playlist looking at compound shapes. So in order to be successful at this, you already need to know how to work out the area of a rectangle, a triangle, parallelogram, and a trapezium. We're not looking at circles yet. That will come after the circles lesson. So we'll look at compound shapes and what it means, and then some examples of questions. So first of all, a compound shape is something that's made up or composed of lots of different other shapes, potentially just two, but it might be more. And here are some examples of compound shapes. What you're going to notice here is, for example, we could say that this L shape here, which we would call a rectilinear shape because it's got a bunch of right angles, we could split this up into two rectangles. And there are other things we could split this up into as well. For example, this shape here, the T shape, could have two rectangles here. This kind of house cross section might be split up into a rectangle and a triangle, or this shape at the bottom here might just be two trapeziums next to each other. There's lots of different ways we can split shapes up. We're going to look at those, and we're going to look at what's the most efficient way to work out areas of these shapes, and potentially even missing length. So for example, here you might be given the area and you need to work out the missing length. So we'll look at that. Now here's an example of a composite shape, and see if you can spot how you would split this up. So you can probably see this one's quite an easy one to split up. You may, for example, decide to split this up into a parallelogram, a rectangle, a triangle, and then another rectangle. So lots of different ways to split this shape up. In this case, this is probably the most obvious way. So let's look at these rectilinear shapes. Now I've got 4 copies of the same shape here. The question is, how would you split this up into shapes that you know, so basic shapes like rectangles, triangles, trapeziums, etc., using the minimal number of shapes? Because what you don't want to do is split this up into, for example, this is a bit of a silly example, but if you split this up into lots and lots of different rectangles, technically does work, but it's not going to be very helpful. What we want to do is the minimal number of shapes. So think about at least 3 different ways, and then I'll show you what I think you could do. Okay, so here is one example. You might just split this up into 2 rectangles like this. Another example is you might go across. So you've got this rectangle and this rectangle. Another example is you might go across like this. What you end up with is 2 trapeziums, or trapezii, I think, that's plural. And another example is you might split this up into 3 shapes like this. So if you did more than 3 shapes, you've probably done too many shapes there. Generally, which one of these you use will depend on what other information you're given, and you may have to split this up in a certain specific way. So here's an example of 2 separate trapeziums drawn on the screen for you. How can we split this up? Well, the first way is actually to not split it and just say it's a trapezium. And if you have enough of the measurements given to you, you can work out the area, for example. Another thing we might do is you might split this straight down into a rectangle and a triangle. Don't think there is any other sensible way to split this up. So we're just going to leave it at that. Okay, so we've split up the L shape, the rectilinear shapes. How would you split up a trapezium? So I would hope that is fairly obvious. We can see that, first of all, trapezium, you can work out the area itself, or you might need to split it up straight down here, and you've got a triangle, a rectangle and a triangle. Okay, so another example here. We have a U shape. How would you split this shape up in, let's try 3 different ways. Now remember, you want to split it up into as few shapes as possible. Okay, so pause if you need more time. I'm going to go through some examples. You may, for example, split this up into these 3. 1, 2, 3 rectangles. You might go across like this, and you've got 1, 2, 3. Another way you might do it, it's not as common, depending on the question though, you might need to, and you've got 1, 2, 3. You've got 3 trapeziums. Now there are obviously other ways to do this. You might split this up, for example, into 4 and 5, but generally you won't find yourself needing to do that many splits. Okay, so now we're going to focus on finding a missing length. So you have a rectilinear shape here. Have a think about what x could be. There is a clue in the diagram. Okay, so you may have spotted something here. That is that this length, this 8mm length, plus this x has to add up to 12. So we can actually just use that to help us work out the missing length. Not much maths we need to show for this. It's quite basic. You may not need to write this later on, but because this is an example, I'm just going to do 12 minus 8 equals x. So x equals 4. Okay, so another example here. Can you work out the missing length? Alright, so you may have noticed here we've got this length 7 and we've got this length 4. And we know that if we bring that down, that's going to add up, 7 plus 4. So the x will be 7 plus 4, which is 11 meters. Okay, next, missing length. Pause the video and see if you can work this out. Okay, so we're working out x here. We're only interested in the vertical lengths. So 2 plus 4 is your vertical length. So this is going to be 6 centimeters. We may not need to write much working out for that one. Okay, next question. See if you can work out what x is here. So we can see the vertical height is 12. We've got 3 units already, and then we've got something else left to get to 12. So 12 take away 3 is going to be 9 centimeters. Okay, next shape. See if you can work out the missing lengths and therefore the perimeter. The perimeter is the length of all of these added together. Okay, so first of all, let's find the length. We know that this is 20. So that must mean that this is 15 and this must add up as well to 20. So that's going to be 5. We also know that if this is 3, that's 12. Well, 3 plus something is 12. So that's going to have to be 9. So we're going to add all the green and the red lengths up. So 20 plus 5 plus 15. I can do that in green. But actually, there is a shorter method that we're going to look at in a second. So 20 plus 5 plus 15. That's the green lengths. And then the red lengths are 3 plus 9 plus 12. Now we could do all of this addition, but actually it might just be quicker to notice that it's just 2 lots of 20 and 2 lots of 12. So we can actually just work those out a lot quicker. So 20 times 2 plus 12 times 2. So that's 40 plus 24, which is 64 centimeters. And that's a length, so we just leave it like that. It's not an area, so we don't put squared. Okay, so next one. See if you can do all of these questions. Work out the perimeter. And in order to work out the perimeter, you're going to need to work out any missing lengths. I'm going to give you one tip before you actually do this question, something that you may notice with these types of shapes. If you have a shape like this, any type of rectangle, where you've got steps taken out. So the question on the left has only got one step, this has got 2 steps. What you will find is this length is equivalent to the length I've shown you here, and these 2 lengths are equivalent to that length. No matter how many steps you have, you can actually just ignore this and pretend or treat it as if it's the other way around, just like that. And you're going to see I can actually do this with the steps here. Once I separate these out, the steps I have here, if I rotate it, what you'll find is it's just, you can treat it like a normal rectangle. Now this only works with those specific steps exist. It doesn't work with curves. It doesn't work if things are sticking out of the shape, but it's just something interesting to notice, and you can apply that fact to help you with some of these later questions. Okay, so pause the video, have a go, and then I'm going to show you the answers. Okay, so here are the answers. Check your work. If you have any questions, leave a comment, send me a message. Okay, smash the like button. We have one more exercise. Now I'm not sure if you're going to be able to see this on the video, so I'm going to leave this on the screen and actually zoom in on the first 3 questions. Now the answers are visible here because you can just self-check it as you go through it. So I'm not going to hide them. What you want to do is show the working out and show that these are the answers to these questions. And pause the video to have a look at these. I'm going to go to the next set of questions as well. So here are the answers to the next set of questions on the bottom, and for you to try on the top. Okay, so hopefully that was useful. We're going to continue looking at compound shapes in the next video.